Welcome back, Math 1. I had to abruptly finish that first factoring trinomials video because I ran out of time. Here are the last two examples from the notes. All right, so you might still be really confused about what's going on here. I'll try to break it down even further. So when you look at number 3, negative 3 plus 4x squared minus x. The first thing I want to do here is I want to rewrite this polynomial in standard form. If I try to go any further without putting it in standard form, things will not go well. Standard form all the way. So standard form is I need the x squared term first, then the x term, which I'm going to put a coefficient in front. Negative x is negative 1x. And then minus 3. Make sure you do that first. Okay, then identify your A, B, C. You don't have to write this step down, but I don't know, it might be helpful if you're having trouble managing the steps. So A is 4, B is negative 1, C is negative 3. All right, then we make our chart. AC is A times C. So this is the multiplication column. B is just what factors of this add up to B. So AC is 4 times negative 3, which is negative 12. Our B is negative 1. Now again, we can write out all the factors we want for negative 12. It won't take us long. There's not too many of them. Negative 1 times 12, 1 times negative 12, negative 2 times 6, 2 times negative 6, negative 3 times 4, 3 times negative 4. And again, only one of those sets actually makes sense because only one of the sets adds up to negative 1. 3 plus negative 4 is negative 1. It's this one. Okay? So that one, that one, that one, that one, and that one don't work. This is the only one. So you are replacing, it's like this. You're replacing negative 1x with 3x minus 4x. And that's a perfectly legitimate replacement. That's like me saying, you know, instead of having 5, I have 2 plus 3. It's like, well, yeah, that works. So we are going to take the middle term and we are going to break it down into 3x minus 4x. I'm actually going to group the 3x with the negative 3 and the negative 4x with the 4x squared. I think it just makes more sense to do it that way. So 3x goes here, and it's positive 3x. Negative 4x will go here. Okay? I'm splitting the middle up into these two, which then creates a 4-term polynomial. 4x squared minus 4x plus 3x minus 3. And once you get to that point, factoring by grouping, sort of like your muscle memory takes over. You've been doing factoring by grouping for a while, yeah? Okay, let it take over. First group, 4x squared and 4x. Looks like 4x is the shared term. So the GCF is 4x. We divide by 4x now to determine the leftovers. So 4 divided by 4 is 1. X squared over x is x. 4x divided by itself is minus 1. And then our GCF over here, they're both, it's 3, you know, and I'm going to keep it as a positive 3. Because if I divide this by 3, I get a positive, and if I divide this by 3, I get a negative, and that's exactly what I want. All right, and then the GCFs become kind of like one group, a one-group binomial. And then the leftovers, there you go. All right, I had one more example that had one little quirk to it. right, these are pretty big numbers. But I think we can easily determine the A, B, and C, right? 18 is A, negative 63 is B, and 27 is C. So, I mean, technically we can do our AC chart. Let's see here. These look like big numbers. I think 18 times 27 is, I think, 486. Let me double check that, please. All right. And then B is negative 63. Okay, there's a lot of terms for 486, so let's get started. Wait a second. I just noticed something. 18x squared and negative 63x and positive 27, they actually have a GCF. They all share something before I can even begin this process of trinomial factoring, AC method. What does 18x squared and negative 63x and 27 all share? They share a 9. So what we can do to get this thing started is we can say right away, you take the 9 out. Take it out. Take it out, take it out, take it out. The leftovers you have are now 2x squared. 63 over 9 is 7. Minus 7x plus 27 over 9, that's plus 3. Okay. We have a much more manageable polynomial now to work with. Look at this thing. Small numbers. So that's the benefit of recognizing a GCF is there and can be taken out right away. Because now, I'm not going to deal with 486 and negative 63. No siree, Bob. What I'm going to do is I'm going to say my new A term is now 2. My B term is negative 7. My C term is 3. All right. AC is 6, not 486. My B term is negative 7, not negative 63. Which makes things very easy because look, negative 1 times negative 6 is our group of factors. Like you can find it instantly. It would have taken me a long time to roll through 486 to figure out what added up to negative 63. This one took much, I don't know, you had to determine the GCF, but look, it's sort of like more manageable bite-sized steps that get you there. So now what we do is we kind of just like ignore the GCF for now. We'll bring it back in the final answer. But we take 2x squared minus 7x and we say the negative 7x needs to split up into minus 1x minus 6x. Okay? That's where those two come from. And then I'm just going to proceed as usual, factoring a 4-term polynomial using factoring by grouping. So the first two group, they share, they don't really share a constant, but they share an x. So if I divide by x, I'm going to get leftovers of 2x minus 1. For my second group, I got to take a negative out. Or wait. Oh, I'm sorry. That should be a plus. Yeah, I got to take a negative out to create a positive negative. Right now I have a negative positive. So it looks like they both divide 3. If I take out the negative 3 as my GCF, 2x minus 1. I've got the identical twins I've always wanted, and now we can reverse that last step. GCF is now x minus 3. Those two GCFs create 1 for the factoring move, and then 2x minus 1 here. Now don't forget, this polynomial inside is perfectly factored. But the 9 on the outside, it doesn't just randomly disappear. It's still a part of the factoring multiplication. So this 9 is going to come right back into it at the end and be a part of the final answer. All right, guys, this is kind of it's a really new concept that can be a bit of a struggle at first, but I tell you, if you communicate with me, and I will attach some other YouTube videos that people who are a lot smarter than me are explaining it maybe a little bit better. And, we'll see what we come up with. I will assign 6 problems, and I will give you guys worked out solutions for, it's like 12 problems. The odd solutions are given to you. So I want to highlight this. I just really want to encourage you guys to use these worked out solutions to your advantage. Because sometimes I feel like you guys maybe aren't even looking at them. But if you're struggling, I think just trying to mimic my work might be a good first step if you don't know what you're doing. It's kind of like try pretending like you know what you're doing until you get to the point where it's like, oh, this is starting to actually make a lot of sense here. But I guess what I'm saying is, if you can't seem to produce anything, but you have this staring at you, I think it might be a good idea to just try to do what I'm doing here. Okay, so hopefully that made some sense. I guess what I'm saying is use the resources I'm giving you guys, and yeah, I'm talking too much now. Hope you guys found these videos helpful, and ask any questions you guys may have.